morning, everybody. I guess we're all online today. So, once again, I do not yet have the audio working. I'm so close. I got it working this morning. But then the computer decided to change its mind and said, no, you don't need that. So, it's unfortunate, but we will persevere. So speaking of, let us turn to last week's drawings. We were practicing some 3D sketches. So here is my final renditions. Go ahead and open yours up. Compare, contrast. There's a lot of room for interpretation here. Of course, this is not a specific drawing. It could be bigger, smaller, longer, taller. But there are some specific features you need to have, right? This thing should be composed of all rectangles and look like parallelograms on the 2D plane, but imagine as a 3D object they will represent rectangles. Of course, make sure your diameter is greater than the height, so this should be a nice wide-looking can. 3 gives you a square base prism, and 4 gives you a pentagonal-based prism. Number 5, sliced open, gives you a rectangle, and number 6, sliced that way, leaves a triangle. Number 7, if you count them all up, a 4x3x4 has 48 total little cubes there. And I started with this face as my scene, so I had 12 of them I could see here. I already counted these 4, so that means there's 12 more here. And then I already counted these and this row, so there's only 6 more there and the bottom, so I can see 30 of them. That leaves 18 hiding on the other side. And then finally, we have our hidden lengths of x and y. This much is 4, here is 2, so then this height, the same here, the same as there, would be 2. Same with y, this whole length across there is 4. This much is 3, that leaves 1 left for the length there of y. All right, did anybody have any questions on this page from last week? Okay, then today we begin with triangle relationships as you read about over the weekend. Please take out your notes from that weekend. And we're going to go over what you should have uncovered for your conjectures. There were lots of methods proposed throughout the book. One had you just drawing, one asked you to draw on one sheet of paper and hold it over top of the other sheet of paper. Okay, I also included a link to some digital tools that you could explore these relationships to try to figure them out for yourselves. So then let's see what we had for our first conjecture. Remember, it is a conjecture because we haven't proven it yet. We are just using inductive reasoning. We're saying, okay, I tried 50 different linear pairs, right? If we were to measure 50 different linear pairs, I think at this point, I'm pretty sure they always do this. But we haven't proven that it's guaranteed to work for all of them. There might be some really special combination out there. It works for all of them, all except that guy. That's the one exception to the rule. We haven't uncovered him yet, if he exists, right? So that's why we're hedging our bets. We're saying this is a conjecture. We're pretty sure, but we haven't proven it with absolute certainty yet. Okay? Later on, much later, probably not till next semester, we'll actually look at some of the proofs for some of these things, and then they'll become theorems. They'll be a little bit more official. So, a linear pair. If 2 angles form a linear pair, that is to say, you have a line and something coming off of that line that should itself be a straight segment. There we go. These two angles here, not necessarily equal, but they will be what? Go ahead and type into chat. What goes here in the blank? Then they are very good. Chris, do we have a word for that? Your number is absolutely correct. We have a vocabulary term. Chris is the only one that knows? We actually looked at an example of these last week. I guess that would be Tuesday, I think, when we went over all the types of angle relationships. I mentioned one of them. Okay. Edlin, same thing. Yes, you are correct. Is there one term that means all of that? Adjacent is technically correct as well, but we can be a little more specific. That is true. They will also be adjacent. Every linear pair, I think by definition, will also be adjacent. That's not as helpful though. Looking for a term that relates their measurements. It's not congruent. Look at my picture there. That's a linear pair. Those two are definitely not congruent. But they will add up to something, and we have a word for that. It starts with S. Supplementary. There we go. Very good, Gisela. They are. Why did it? Okay, that was weird. Supplementary. If two angles form a linear pair, then they are supplementary. Write that down. Go back, change your notes if you have to. You need this term belongs in Conjecture 1. Two angles form a linear pair. They are automatically supplementary, and thus supplementary meaning add up to 180. If you need a reminder for yourself, go ahead and write that down. Add up to 180 degrees. Okay, so when I give you one angle, if we say this guy is 100 degrees, you should be able to find the other part of that pair quite easily, right? You know, hey, both of those combined have to equal 180, so I can just take 180 minus 100, and in this case, you'll be left with 80. So we could figure out this one must be 80 degrees, right? You're gonna have to do that quite a bit. All right, next one, vertical angles. Vertical angles, remember, are the opposite sides of an intersection. I take two lines and crisscross them whichever way I want. If we talk about one angle here, think about the catty corner, opposite side of the intersection, all the way, right here. What is this angle? How do those compare? If two angles are vertical angles, then they are what? It's not supplementary this time. Complementary, good guess. It's not complementary. Take a look at how the sizes actually compare when I adjust one of my lines. So I want you to focus on the left side and the right side. What happens to those angles? Notice when the angle on the left is really big, get out of there. On the left is really big, the right is really big. When the left side is really tiny, the right side is really tiny. So what do you think it's got to be now? It is congruent this time. Very good. They are congruent, or if you don't like all that writing, you can, of course, use the symbol there. They're going to be congruent. So this angle will be congruent with that angle, and every intersection forms 4 angles. So actually we get this side is congruent to that side. The opposite angles on an intersection will always be congruent. They are vertical angles. If 2 angles are vertical angles, then they are congruent. But notice the language we've used here. We've written this as an if-then, a conditional statement, so that we could use it in a logical argument if you wanted to, say, prove something later on, right? That's why we have that language there. All right, any questions on linear pairs or vertical angles? Okay, quick detour. Your exercises for today up here are going to be given you some sets of angles, and you will have to find their values based on the given information, right? So look here. This guy and this guy are vertical angles. They are on opposite sides of the intersection. A and this marked angle are along the same side as a line, so A and the marked angle are a linear pair. Okay, so if you know what this angle is, then you can figure out A. And they've also kindly marked this one as the same as that opposite one over there, which is kind of neat. Right, so you can use that information to solve any of these without having to do any measuring. You can just work out, this has to be the same as this one's supplementary to that, and you can work through and determine the measurements of any of these angles inside the diagram. Okay? Do watch out for the square box, meaning that it is a right angle. Don't forget about that one. All right. And then this will be more question-based, but that's the main event. These types of diagrams and problems will appear on the SAT. There's almost always at least one having you figure out angles from one thing or another. But they also like to throw in the parallel lines. So let's come back to our conjectures here. This is from the next section, but I want to go ahead and go through all the conjectures today, and then we can spend more time practicing with the parallel lines tomorrow. So when you have a set of 2 lines that are parallel to each other and they are cut by a transversal, this third line here is called the transversal, then the corresponding angles, that is to say angles in the same position. If it's in the northeast corner here, it's in the northeast corner there, they correspond to one another. They're in the same location. What does it look like? What would you guess if you were to look at those 2 angles, 2 and 6 there? What do you think the relationship between those is? Their measurements. How would you compare them? Got one guess already in. There's 2. Yeah, very good so far. Congruent. They are congruent. Absolutely. Corresponding angles in parallel lines. Let me take this moment to tell you, only if they are parallel lines. Let me draw a quick little sketch in the middle here. If I had this line, that line, and the transversal here, these guys are corresponding angles. All right, they are still in the same relative corner of the intersections there. Here's intersection 1, this guy is in the upper right, here's intersection 2, upper right. But these two lines are definitely not parallel. Therefore, I cannot conclude that these angles are congruent. Okay? This only works if they are parallel. Keep that in mind. Okay, next up we have the alternate interior angles. This one's really fun because this is the Z. See that? The Z angles. Alternate interior angles we shorten there, AIA. What do you think is the relationship between those angles? I need some new answers in the chat. What's the relationship between the alternate interior angles of parallel lines? There we go. Thank you, Naomi. Yes, they are congruent. Very good. Once again, if the two parallel lines cut by a transversal, then the alternate interior angles are congruent. Okay? They have to be parallel. Now, how about these guys? The alternate exterior angles. If we go on the outside and alternating because they're on opposite sides of that transversal, right? Notice from this line, one is on the left side, one is on the right side. They're on opposite sides of the transversal. And now they are outside of the parallel lines. They're on the exterior. How do they compare? Also congruent. Absolutely. It's starting to sound like all of these angles are just congruent to all of the other angles. It certainly seems that way so far. Just wait, just wait. There is, wait, actually, do we have a conjecture for it? There is one relationship where there are not. We'll get to that soon enough. All right, since these are all the same relationship, we can say the corresponding angles, the alternate interior angles, and the alternate exterior angles are all congruent. We've summarized that one together here to say, all together now in one sentence, it's just the shorthand, if two parallel lines are cut by a transversal, then corresponding angles are congruent. alternate interior angles are congruent, and alternate exterior angles are congruent. Right? So this final one, conjecture number 3, just sums together parts A, B, and C there. All right, and then finally, this is very important because this is the converse of the parallel lines conjecture. Remember, I was emphasizing, if they are parallel, then these angles are congruent. It turns out the converse is also true. If I work backwards, it's still true. Remember, we learned last quarter that that's not automatically given just from a logic standpoint. But here, the geometric situation dictates, yes, it is the case. This time, it does work. The converse is true. If I take two lines cut by a transversal, and I get congruent corresponding angles, congruent alternate interior angles, or just congruent alternate exterior angles, any of the above, if I check any one of those and they are congruent, then the lines are parallel. Right, you can use the symbol there or write out the word. So let's say you're looking at some lines here. You're like, I don't know, the drawing, it's not quite the case. I can't really tell. Let's take some measurements. What if I go this one, it's like, oh, that's 37 degrees. And then you find out this sky is also 37 degrees. These form the Z in the middle, alternate interior angles, 37 equals 37. The same measurements, those angles are congruent. So hey, alternate interior angles are congruent. Therefore, the lines must be parallel. Okay? That's the thought process there. I can use that to prove that they have to be parallel. And if we know they're parallel, I can use that to prove that these two angles must be congruent. That's pretty neat, huh? You can work both directions there. We'll play more with that tomorrow, as well as bring in the final relationship. What pairs of angles are not necessarily congruent? We've got a few more to go there. Any questions on that material so far? Okay, then I leave you with the rest of the day to answer questions. It looks like solid 1 through 15 here on the section 2.5 practice. And then, as already stated, tomorrow we'll do the 2.6 practice, which incorporates those parallel lines that the SAT absolutely loves. There is always at least one question with parallel lines and angles in the middle.